So let's get started. Let's start with linear relations. So linear relation is just a polynomial of degree 1. So if you remember what a degree is, it's just the highest power of that polynomial. So let me just get the annotation up. Okay, so polynomial of degree 1, so anything with a power of 1. So this y equals mx plus c, that's basically y equals m times x to the power of 1 plus c. So that's what's happening here. And here c is your y-intercept. Or actually, I should have circled the plus c. So plus c is your y-intercept. So you can have a negative y-intercept, positive y-intercept. Doesn't matter. And remember, y-intercept occurs when x equals 0. So let's say we substitute x equals 0, m times 0 plus c, y equals plus c. And m is the gradient. So if you don't remember what gradient is the slope of the graph. So it's basically how steep is it, or how sort of flat is it. Let's do this one. So solve the following for x. Let's see what's been done here. So you've got 2x plus 3 equals 2. Subtract 3 from both sides, so 2x minus 3. So 2x plus 3 minus 3 is just 2x. 2 minus 3 is negative 1. And then x equals negative a half because you're dividing both sides by 2. So being able to solve linear equations is a really important skill. Hopefully you've been working on it. I think you would have started working on solving linear equations since maybe even year 8. So it's something that you should be confident by now. An exam tip, it's a good idea to sort of highlight your answers. So either underline them or put a box around them, just so the examiner can know straight away what your answer is. Okay, so following on, you need to know how to calculate the distance between 2 points. And you just use this formula, and you don't have to memorize it. You can sort of figure it out. So let's say you have 2 points. So you've got x1, y1 here, and you've got x2, y2 here. So those are the 2 points. And here is the distance that you're trying to calculate. Okay, you've got A, B, and D. And keep in mind, this is a right angle triangle. So hopefully it's looking familiar now. AB, right angle triangle, you want to find the hypotenuse. So hopefully Pythagoras is coming to your mind. So A is the horizontal distance. So x2, so that's from here to here. x2 minus x1, that's a horizontal distance. And B is a vertical distance. So y2 minus y1. So that will give us our vertical distance in this scenario. Remember Pythagoras, a squared plus b squared equals c squared. Here, your c is basically d here in this instance because it's just a distance. So remember, a squared is x2 minus x1 squared, b squared is y2 minus y1 squared, and that's equal to d squared. And then to get d, you have plus or minus square root of x2 minus x1 squared plus y2 minus y1 squared. But you can't have a distance that's negative. So a distance is always a positive value because it's sort of a measurement from one point to another. So you can't go negatively from one point to another and find that distance. So distance is greater than 0. So that's why distance is only the positive value of that square root. So distance is plus square root of x2 minus x1 squared plus y2 minus y1 squared. So here, if you ever forget how to calculate the distance between 2 points, that's okay. If you forget the formula, no big deal, because you always have Pythagoras. You can always use your logic to figure it out. So it's not on the formula sheet, so it's really important that you memorize it or you can figure out how to calculate the distance. I think it's a good idea to memorize it because it would save you time. It would save you from having to apply that logic, and you won't even get extra marks for, drawing this diagram unless you're actually asked to. So an example, so find the distance between 0.01 and 24. So first, this is the first thing, so recall that the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the first thing to recall. Second thing, substitute your points. So your first point is 0 and 1, so that's this and this. And your second point is 2 and 4. So you don't have to actually have this step. I'd say all of this is step 2. You don't really need to show which you're substituting first and which you're substituting second. So you can just go straight from here to here and skip that step in the middle. Okay, now simplify it. Distance is negative 2 squared plus negative 3 squared, 4 plus 9. So distance is square root of 13. And remember, distance is positive. So obviously it's going to be a positive square root. Okay, so that's it for distance. Really important concept. Something that's related to distance is midpoint. So if you have a line segment, so line segment is basically you have 2 points and a line joining them. The midpoint is your middle point of that line segment. And to find that middle point, we basically average the 2 coordinates. So midpoint is x1 plus x2 divided by 2. So you have 2 coordinates divided by 2. That's the average of those 2 coordinates. And then here, y1 plus y2 divided by 2, that's the midpoint of the y coordinates. So for example, if we were to try to find the midpoint between 1 and 2 and 3, 4, so if you want, you can pause the video here and work it out yourself. So now's a good time to pause if you want to. Okay, so to work this out, substitute into the formula. Again, you don't really need this first step. You don't need to show what you're substituting first and what you're substituting second. You can just go straight and do this as your step. So midpoint is 1 plus 3. So 1 and 3. And then 2 plus 4 divided by 2. And that's 4, 2, 6, 2. And remember, midpoint is a coordinate. So make sure that you give your answer as a coordinate. Don't be like x equals 2 and y equals 3, because you're not giving the midpoint coordinate now and you're not answering the question. So it's really important that you read the question and you give that answer as a coordinate for the midpoint. Okay, next we're going to be talking about gradients. So this is a concept that's probably been introduced to you a few years ago. But gradient is your rise over run. So essentially, how much does the y increase for the every time? So let me rephrase that actually. So for every 1x, how much y is there? So every time the x increases, how much does the y increase by? So that's your gradient. It's basically the change in y over the change in x. The change in y per the change in x. So based on the change in x, how much does y change? So it's basically the slope. So for now, all you need to know is the gradient is the slope of a line. And you can calculate it as rise over run, or you can basically do y2 minus y1 divided by x2 minus x1. Both will give you the gradient. This one, so this equation here is just a way of rewriting that first one. For example, find the gradient of the line that passes between the points 1, 2 and 3, 4. So you can use the gradient between any 2 points on the graph. So it helps you find the equation. So let's actually figure out the gradient. So remember, gradient is y2 minus y1 divided by x2 minus x1. So they've decided that this is x1 and y1. And this is x2, y2. It doesn't matter which you pick first and which you do second, as long as they're corresponding. So as long as you don't do y2 minus 2 and x2 minus 3. So as long as you don't mix up those coordinates, you're fine. Okay, gradient is 4 minus 2, 3 minus 1. Again, you don't need to include this line of working out. You can just go straight to here. It might be a good idea to do m equals y2 minus y1 on x2 minus x1, depending on how many points there are. So if there are 2 marks for this question, it might be a good idea to add this as well. So show the formula that you're getting the gradient for. And then gradient is 2 on 2, or gradient is 1. So here your gradient is 1. So what that means is every time x increases by 1, y is also going to increase by 1. If your gradient was 2, it's going to tell you every time x increases by 1, y increases by 2, and so on. So just emphasizing that, to find the gradient, you can have any 2 points on the line, and it will help you find the equation of the line as well. Okay, so gradient can also be represented using angles. So let's say you have a graph that's like this. So you've got y, you've got x, and let's say it's going like that. This is an angle. And if the angle is bigger, it's telling me that the graph is more steep. If the angle is smaller, it's telling me the graph is more flat. So you can use this angle to figure out the gradient. So you can say tan theta is rise over 1, and then that theta is tan inverse of rise over 1. So now we're going to talk about how we actually get that. So let's say we have a graph here. So that blue line is our the equation of our line, and that red theta, that's our angle. So we've got theta equals tan inverse of 4 minus 2. So we've got 2 points. This is x2, y2, and this is x1, y1. So tan inverse of 4 minus 2 divided by 3 minus 1. So tan inverse of the gradient, that's tan inverse of 1, which is theta is pi on 4, or 45 degrees. So if you're not really sure what this pi on 4 means, don't stress about it. When you get to circular functions, it'll start to make sense a bit more. But for now, you can use 45 degrees. Okay, so vertical and horizontal lines. So this is something people get quite confused by, especially when asked for what the gradient is for a vertical or horizontal line. So for a vertical line, it's expressed as x equals a. So you've basically got a line. So you've got y, you've got x, and x equals a, might be here. And it's basically parallel to the y-axis. So basically, regardless of your y value is, x will always equal to a. So if I was like x equals 1, and that's my vertical line, then whether y is negative 100, whether y is 0, x is still equal to 1. So this is an example of that line. So y can be 3, and x is still equal to 1. Y can be negative 6.67, and x is still equal to 1. So regardless of the y value, x is always equal to that constant. Now horizontal lines, so that's y equals b. So it's in that form. So basically you've got y, you've got x, and this could be the line. So y equals b. I know my drawing isn't perfect, but you want this line to be parallel to the x-axis. So regardless of what the x value is this time, y will always equal b. So whether x is 100, negative 1,000, y is always equal to b. So here's an example. So let's say y is equal to b. Here, if x was 10, y is still equal to b. If x was negative 10, y is still equal to 1. So here we've got y equals 1, and here we've got x equals 1. So hopefully that makes sense so far. Okay, parallel and perpendicular. Oh, actually something else I want to add about vertical and horizontal line. So people get confused about the gradient of these two lines. So this vertical line, think of it this way. So let's actually start with the horizontal line. So think of it as the slope of that line. Here, the line is so flat, it has no slope. So the gradient equals 0. So it's so flat that it has no slope whatsoever. That makes the gradient 0. Here, it's so steep that we can't even put a number to the gradient. So for this one, the gradient is undefined. So it's so steep that it's like we can't even assign a number to that gradient because of just how steep it is. So hopefully that's a good way of remembering for you. Okay, so now let's talk about parallel and perpendicular lines. So if you have a parallel lines, they basically have the same gradient. So they never intersect, and the gradients are the same. So the gradient of line 1 and the gradient of line 2 are equal. So for example, let's say we've got y equals 2x plus 4 and y equals 2x minus 3. You have the same gradient, so that 2. And that tells you that these two lines are parallel. Perpendicular lines, so basically they intersect at right angles to each other. So basically they are perpendicular. And for perpendicular lines, the gradient of that first line is the negative reciprocal of the gradient of that second line. So basically what that means is the gradient is negative 1 over the gradient of the other line. For example, y equals 2x plus 4, y equals 2x minus 3. So these are parallel, but to make them perpendicular, you go, not parallel, y equals, and the gradient is negative 1 on 2, x, and then plus any constant, plus c. It can be anything. Okay, so here, parallel lines. So here's an example of parallel lines. So we've got y equals 2x plus 4, like in the example, and then y equals 2x minus 3. So you can see that they're perfectly parallel. They're never ever going to intersect. They're always the same distance from each other, and that makes a parallel line. So same gradient, different y-intercept means that they're parallel. Here, perpendicular lines. So we've got, okay, so this is the perpendicular line, negative a half x plus 1. This is our original line, 2x plus 4. And we need to be aware that they intersect at right angles to each other. So really, really important concepts, and you'll be asked to apply these concepts this year, so in 1-2 methods and in 3-4 methods. If you want to find the equation of lines, so linear lines or just lines in general, you need two pieces of information. So you can either have 2 points on that line, you can have the gradient of that line and the point that lies on the line, or you could have the y-intercept and the gradient. So essentially that's still gradient and the point that lies on the line. You can use y equals mx plus c or y minus y1 equals mx minus x1. So this one is your actual equation. This is something that you can use to get to the equation. So I'll elaborate on both of them in a little bit of time. Okay, so linear equations, you can have one, none, or infinitely many intersections. So I should clarify on this. I should say that let's say you have 2 linear equations. Those 2 linear equations, when you plot out those lines, you can have one intersection between those 2 lines. You can have no intersection between those lines, or infinitely many intersections between those lines. So if you want to have one intersection, all you want is that they're not parallel, so they intersect once at some point. 0 intersection means that you want them to be parallel. So you want M1 equals M2, but you don't want C1 equals C2, and I'll get to why in a bit. Infinitely many intersection means you essentially have the same line. So here you got M1 equals M2, C1 equals C2. So that's basically you have the same line. One intersection, you want M1 is not equal to M2. That's your condition here. If you have different gradients, there'll always be one intersection. If you have the same gradient but different y-intercepts, they'll be parallel, the lines will be parallel, and there'll be no intersection. And if you have infinitely many intersections, it means that those 2 lines are exactly the same. So the gradient is the same, the gradients are the same, and the y-intercepts are the same as well. Okay, so that's it for linear equation. If you need a break, you can pause, have a drink of water, stretch. But